Section 4.5, graphs of sine functions, looking at examples now of what we had just talked about. So the first one, f of x is equal to 1 plus 3 sine of 2x. Think about the things that each of these represent. You have your d value, which is your vertical shift up and down. You have the a value, which has to do with your reflection and your vertical stretch and compression. And then you have your b value, which has to do with helping you find your period. What you don't have, or at least you don't see, we could put it in here, would be the c value, which means that is your horizontal shift, left and right. So we don't have any shift or horizontal shift left and right on this one. So let's write down what we know. The amplitude. The amplitude is the multiplier of the function, so that will be in this case 3. That's that vertical stretch. The period, remember to find the period, we take the initial period, which is 2 pi, and divide it by the b value. And so 2 pi divided by b, which is 2, would be pi. So what that does is, remember, since b is actually 2, it's a compression. So now instead of the period being 2 pi, it's a little bit smaller, it's pi now. And then we take the period and divide it by 4. And so the period would be, or the interval would be 1/4 or pi over 4. So we're breaking it into fourths. Vertical translation, we do have a vertical translation. It is shifted up 1 unit. That's your d. Remember, you're adding that to your y value. Once again, think back to transformations, just like we did all the other functions. And then is there a reflection? The reflection comes from negative the function, which you're going to see with that a value. We don't have a negative there, so there will be no reflection on this one. We already know your domain because you can plug in whatever you want. Will all be all real numbers. The range will wait until we have it graphed. So let's mark this into fourths. So 1/4, 2/4, 3/4, and 4/4. Our period is 1 pi. So that's where the graph is going to start to repeat. So we break this up into fourths. So this would be pi over 4, 2 pi over 4, which would be pi over 2, 3 pi over 4, and then 4 pi over 4. I'm also going to extend this out for another period to 2 pi. And also on the negative side, just to get you to realize this does go in both directions, over here would be negative pi. Now, first thing, it does shift up 1 unit. So I think one of the easy ways to look at this, and there's a couple ways that we can do this, but I think one of the ways to look at this is actually to say, okay, I'm going to shift my entire graph up 1 unit. And I'm going to make that a dotted line just to kind of show you that this is a shift up 1 unit. All right? So my entire sine graph has been shifted up 1 unit, which means now, remember what your parent function of the sine graph looked like. It started at 0, 0, went to the max, the middle, the min, and the max, or the middle. So it looked like that. So we're going to have the same shape, it's just that it's going to be shifted up 1 unit, and my amplitude is going to go up to 3. So if I shift, what my originally start point was at 0, 0, if I shift that up 1 unit, my new start point is going to be at that 0, 1. So I'm going to go ahead and label my y like I labeled my x. This would have been 1, 2, 3, and 4, and then negative 1, negative 2, negative 3, and negative 4. So now I'm starting at 0, 1, and I'm going to go to my max point. Well, where's my max point? My max point is with my amplitude of 3. It's getting stretched by a factor of 3. So I'm going to go all the way up to 4, because that's that factor of 3. So I'm at my middle, then I'm at my max, then I'm back at my middle at pi over 2. My next interval, I'll be at my min. So I want to go down 3 units, because that's that vertical stretch still. So 1, 2, 3, that'll be at negative 2. And then at the end of my period, I'm back at 0, 0. So look at those 5 points. Middle, max, middle, min, middle. All right? And I'm actually going to go ahead and continue for another period. So then my next one would be, I'm back at the middle. So I'm going to go to my max, back to the middle, to the min, back to the middle. Okay? So your sine curve, there's the max, the middle, the min, the middle, the max, the middle, the min, the middle. And it just repeats. I'm going to do that one more time on the left side as well. So I'm at my middle. I was just at my max, my middle, so I'll be at my min. Then the next interval will be back at the middle. Next interval back at the max. Next interval back in the middle. So once again, this also continues in both directions and continues to repeat. So your range, in this case, goes from 4 and negative 2. So your range is from negative 2 to 4. And so that's how you graph the sine function using your transformations. Okay, let's take a look at another one. F of x equals negative sine of x. So your amplitude is the absolute value of the a, which is negative 1. So the amplitude is 1, which means it hasn't changed from the parent function. The period is 2 pi divided by b, which in this case is just 1, so that's 2 pi. And then your interval is a fourth of that, so that's pi over 2. Vertical translation, there should be something that is being added, and there's not. So this one, there is no vertical translation. It's not being shifted up or down. But there is that reflection. There's that negative. So yes, it is reflecting over the x-axis. And that's really the only thing that's going on that's different from the original. Like I said, we're always going to know what our domain is. You can plug in any value. So we start by marking off our intervals, 1, 2, 3, 4. Our period is 2 pi. Our intervals are a fourth of that, which is pi over 2. Pi, 3 pi over 2, those are the 4 intervals. Parent function originally goes from middle to max, to middle to min, back to the middle. So normally it looks like this, but we're going to reflect it. So now each of these points is going to get reflected over the x-axis. So your 3 middle points are going to stay the same, but your max is going to become your min, and your min is going to become your max. So we will label the y-axis as well. 1, 2, -1, -2. And I'll carry out my x-axis a little bit further. We'll go another period of 4 pi, and then on the other side we can go another period of -2 pi. And you don't have to graph, 3 periods, but it kind of shows you a nice full length of the graph. So here we go. We still start at 0, 0. Normally we would go to your max value at 1, but because it's a reflection, we go to the min. It reflects over the x-axis. We're back to the middle, to the max, and then back to the middle. So there's one period of your graph of y equals negative sine of x. I'll go ahead and continue it for another period to 4 pi. And so it would continue like that as well. So there's an example of f of x equals negative sine of x, where you see that reflection across the x-axis, and the range we now know is from here to here, from 1 and -1. So your range will be from -1 to 1. So in this example, really asking you to just describe the changes in the graph. So you're looking at the parent function f of x equals sine x, and then I want you to consider the amplitudes, the periods, and the translations, and describe the differences between the graphs of f and g. So just to point out a couple of things here, you can see that your d is right here, so that's your vertical. You have your a and your amplitude right there, which tells you your vertical stretch and compressions, also your reflections. And then your b value right there, which helps you identify your periods, which is one of the things that's asking for. And once again, you don't see it, but there's a +0, and that represents your c. So let's describe what is going on here. Let's just kind of start with the first one in terms of d. So since we know d is equal to 3, what does that tell us? Well, we know that if d is equal to 3, that we will have a vertical shift. Three units up. So we'll have a vertical shift 3 units up. And that's different from the parent function. Let's go to the next one, which is the a value being a negative and 2. So 2 has to do with the amplitude. So the amplitude is 2 compared to the original, which it's 1. So it's twice the original. So the amplitude is twice that of the function f of x, because it's asking you to compare. So the amplitude is twice that of the function f of x. It is also a reflection, so we're going to add that. So g of x is a reflection of f of x. And then the b is going to help you find the period. So originally it's 2 pi, and so let's go ahead and calculate what it will be now. It'll be 2 pi divided by 1/2, which is 2 pi times the reciprocal, so that would be 4 pi. So this represents the period. So the original is 2 pi, now it's 4 pi. So the period is twice that of the original. So these are describing the differences between the parent function and the new function g of x. Once again, you're comparing the amplitudes, the periods, and the translations. And I have one more example if you want to watch. It's going to be, once again, one more graphing if you're still needing a little bit more help. So on this one, the amplitude is 1/2. So that's the a value. The period is 2 pi originally, divided by, in this case, b, which would be pi. That's the value in front of x. So our period is 2. And that's 2 radians. That's not, to anything else. That's our measure in terms of our x-axis. The interval is a fourth of that, which would be 1/2. The vertical translation, there is one on this one. It goes up 1 unit. It's just at the end. It doesn't matter. Still being added to the function. And this one does not have a reflection over the x-axis. Your domain, once again, is all real numbers. So our x-axis, remember, those are our angle measures. Now this one does not have the unit of pi in it, but it's still in radians. It's just 2 radians as 1 period, and then the intervals are in half. So this would be 1/2, 1, and 3/2. And once again, I'll mark off another period, which would be 4, and I can also go in the other direction, which would be -2. I'm going to make my y-axis go up by halves. So that's 1/2, 1. This would be 3/2 and 2. And so on the bottom, you get the same thing, just the opposite. So I think I have everything set up and ready to go. We start, once again, think about what the parent function is. It starts in the middle, goes to the max. We don't have a reflection, so it's still going to do that same thing. The one thing that we have to pay attention to is that it does get shifted up 1 unit. So let me make sure I write that correctly. So it's up 1 unit. So this is kind of my new starting point. So where we originally start in the middle of the graph, which is at 0, 0, now the middle of the graph is at 0, 1. So we start in the middle. We go to the max. The amplitude is 1/2. So we're only going to go to 3/2. Then back to the middle at the next quarter mark. Then to the min, which is another 1/2 in terms of the amplitude, back to the middle. Okay, and you can continue to go to the max, middle, min, middle. I'm going to go to the negative side as well. So we went from max, and then we're at the middle, so we'll go to the min, back to the middle, max, back to the middle. So it will look like this. And that represents, I think I have 3 periods there. So it does continue on, so get those arrows on the graph. Our range, you can see, goes from here to here, which would be 3/2 as the max, 1/2 as the min, so the range would be from 1/2 to 3/2. And so there's another example of graphing a sine function.